So in the first video in this section, we went super deep into these theoretical ideas about tangent lines and secant lines, and I probably got you really confused, but I was like, don't worry, in the second video we'll do some calculations and it'll make way more sense. And I think for most students it probably did when we calculated the slope of the tangent line at a given point, like f prime of 3, or even f prime of 2, or f prime of 1. And you're like, all right, I got this, calculus. I don't know why they make it such a big deal out of it. It's not that bad. I totally understand. And then I ended the last video by not calculating f prime of 2, but instead calculating f prime of x, which is hard algebraically, but mind-blowing if you think about it theoretically. For those that I lost at that point, you have good news. The remaining 3 videos in this section are just going to be getting practice with that and showing you algebraically how to calculate f prime of x for different functions f. Because they're different functions, I'm going to give them different names. In this case, we'll call this function g of x. It's 1/4 x cubed minus x plus 1. Note that this is a cubic function. We see an exponent of 3. Unlike this function up here, that was a second degree function. There's 2 types of questions that we'll answer in this video. The first one is, let's find the slope of the tangent line to this function g at the point where x equals -2. If you could translate this question into, aren't you just asking me for g prime of -2? That would be awesome. You don't need the tangent line represented visually, but for those that it helps, here it is. How steep is this line? You could estimate it geometrically, but it makes a lot more sense to calculate it algebraically. To figure out g prime of 2, what I want to do is take the limit as h approaches 0 of g of a plus h minus g of a divided by h, where playing the role of a is the number -2. So the limit as h approaches 0 of g of -2 plus h minus g of -2 divided by h. To figure out g of -2 plus h, you come up here and change all the x's into -2 plus h's, and then you can put that output right here. Because it's going to be kind of messy, I'm going to do that off to the side. I'm going to figure out g of -2 plus h up top here. It would be 1/4 times -2 plus h to the third power minus -2 plus h plus 1. The problem really comes in this -2 plus h cubed term, because when I'm cubing something, I'm multiplying it by itself 3 times. So you can kind of think FOIL to take care of the first two. -2 plus h times -2 plus h gives me 4 minus 4h plus h squared. That's the product of these 2 parentheses. But then I still have another -2 plus h that I have to multiply that by. So now the idea is I want to take each of these 3 terms and multiply them by each of these 2 terms. If some lines help at all, I want to do this product, this product, this product, and then this product, and this product. You might want to pause the video and do this on your own to make sure you get the same answer that I get. But this 4 times -2 is -8. -4h times -2 is positive 8h. And h squared times -2 is -2h squared. I've now multiplied the -2 times each of these 3 terms. I want to multiply the h times each of these 3 terms. So 4 times h is 4h. -4h times h is -4h squared. And h squared times h gives me h cubed. If I combine like terms and write the exponents in decreasing order just to keep things neat, I got an h cubed here. If I look for my h squareds, I got -4 of them here and -2 of them here. So total I have -6 of these h squareds. If I look for my h's, I got 8 of them here and 4 of them here. So I have 12 of these h's. And then finally, if I look for my constants, it's just this -8. You're like, okay, so if I put -2 plus h in, this is what comes out? No, this is just the 2 plus h cubed part. So g of -2 plus h is 1/4 times that -2 plus h cubed, which I just figured out was h cubed minus 6h squared plus 12h minus 8, minus the -2 plus h plus a 1. It looks like I wrote an h squared up here, but I meant h cubed. If this example wasn't hard enough already, me making mistakes makes it even harder. Sorry about that. What I want to do now is get rid of all the parentheses. So to get rid of these parentheses, I'll take the 1/4 and distribute it through. I would get 1/4 h cubed minus 6h squared times 1/4. 6 times 1/4 is 6/4 or 3/2. So I get minus 3/2 h squared plus 12h times 1/4. 12 times 1/4 is just 3. So I get 3h minus 8 times 1/4. 8 times 1/4 is 2. So I get minus 2. To get rid of these parentheses, I take the negative 1 and distribute that through. So I get plus 2 minus h, and then I still have this plus 1 out here. Combine like terms one last time. I got 1/4 h cubed minus 3/2 h squared plus 3h minus 1h, so plus 2h. Negative 2 plus 1, in other words, plus 1. When I put negative 2 plus h in, 1/4 h cubed minus 3/2 h squared plus 2h plus 1 comes out. But that's just one piece of my equation here, right? That's just g of negative 2 plus h. I also need to know g of negative 2. I need to know what comes out of this machine when I put negative 2 into it. Fortunately, that's going to be a little bit easier to calculate. Negative 2 cubed is negative 8, and negative 8 times 1/4 is negative 2. And then minus another negative 2 is the same as plus 2, and then plus 1. Negative 2 plus 2 plus 1 is just 1. When I put negative 2 in, positive 1 comes out. I now have my two different outputs that go into this formula here. G of negative 2 plus h is 1/4 h cubed minus 3/2 h squared plus 2h plus 1. From that, I want to subtract g of negative 2, which is just 1. And then I want to divide that by h. Nice thing's going to happen. You might be able to see it. This positive 1 and this negative 1 will cancel out. And once that happens, all of the terms in the numerator have an h in them, which is awesome because that allows me to cancel this h in the denominator. What I'd be left with is 1/4 h squared, because one of these three cancels with this, minus 3/2 h, because one of these h's cancels with this, plus 2. What's the limit as h approaches 0 of this expression? Well, it's really easy. Just change all the h's into zeros. 1/4 times 0 squared is just 0, minus 3/2 times 0 is also just 0, plus 2. I get 2 as my answer. Wait, what did I just figure out? G prime of negative 2 equals 2. In other words, the slope of the tangent line to this function g when x equals negative 2, what's pictured in red right here, has a slope of 2. What about g prime of x? Okay, prepare yourself. Instead of asking for the slope of the tangent line at negative 2, what I'm asking for is a machine that'll tell me the slope of the tangent line at any point, not just negative 2. So much more powerful than what I calculated up here. It's going to be an algebraic nightmare, but I think we can do it. Using our formula for f prime of a, we can figure out that g prime of x would just be the limit as h approaches 0 of g of x plus h, not negative 2 plus h, because it's not negative 2 that's the input, it's x, minus g of x divided by h. In order to figure out this mess, I need to know what comes out of this equation when I put x plus h into it. So that I don't have to keep scrolling up, I'll copy the equation g of x, which is 1/4 x cubed minus x plus 1, and use that to figure out g of x plus h. Copy exactly what you see in pink, but change all the x's into x plus h's. 1/4 x plus h cubed minus x plus h plus 1. That's not so bad, but we want to simplify this so that all the parentheses are gone. And because we have something cubed, that's going to be kind of a mess. We'll have to do this step again, except instead of negative 2 plus h, what I'll be multiplying by itself 3 times is x plus h. Because I teach math for a living, I know some shortcuts in doing that. So I'll leave that expansion as work for you if you want to double check my work. But I can just tell you that x plus h cubed is going to end up being x cubed plus 3x squared h plus 3xh squared plus h cubed. If you're wondering where this comes from, the x cubed, the x squared h, the xh squared, and the h cubed are kind of the different ways, loosely speaking, we can allocate my exponent of 3 to the x's and the h's. And then the coefficients out in front, the 1, 3, 3, and the 1, just come from Pascal's triangle, which is kind of wild that that shows up in this context. But I don't want to get into any of that in this video. It's super interesting, but it's not anything you need to know for our class. It's way beyond anything that we're doing. If you ever needed to figure out x plus h cubed, which, side note, you might have to do that once in the homework, but I'd never test you on that because it takes forever. What you'd probably do is just go through this exercise again. Anyways, this is not g of x plus h. We've just looked at this first term here. We still have to subtract x plus h and then add 1. Let's get rid of all of our parentheses by taking the 1/4 and distributing it through. I get 1/4 x cubed plus 3/4 x squared h plus 3/4 xh squared plus h cubed. From that, I want to subtract x and subtract h. Make sure the negative hits both of these terms. I can't tell you how often people forget to make this negative right here. And then plus 1. G of x plus h is this huge expression right here. So when I'm evaluating the limit as h approaches 0, what I'm doing is taking that huge expression, g of x plus h, and subtracting from that expression g of x. Good news about g of x, that's just the output when you put x into the machine, which is exactly what you see on the right-hand side here. 1/4 x cubed minus x plus 1. Be careful with these parentheses. You have to subtract the entire g of x thing. So you have to subtract all three of these terms. Without these parentheses, you'd just be subtracting the first term. And we want to divide that by h. It looks horrible, right? It's the worst thing we've seen so far in this class. And I even forgot to put the limit in here. But the good news is things are going to simplify really nice. 1/4 x cubed minus 1/4 x cubed. Those are just going to cancel out. Negative x minus negative x, which turns into positive x. Those are going to cancel out. 1 minus 1, those are going to cancel out. All the stuff in pink is gone. What I'm left with in blue is just 3/4 x squared h plus 3/4 xh squared plus h cubed minus h divided by h. I can't evaluate this limit right now by changing all the h's into zeros, because if I did, I'd be dividing by 0. But fortunately, every term in the numerator has an h in it, and that's not a coincidence. That's always going to happen. So it's a nice little check that you didn't forget parentheses or mess up a negative sign somewhere in your work earlier. If I factor out an h from each of these terms in the numerator and cancel it with this h in the denominator, I get the limit as h approaches 0 of 3/4 x squared, this h is gone, plus 3/4 xh, one of these h's is gone, plus h squared, one of these h's is gone, minus 1. This is an easy limit to evaluate. I can just change all the h's into zeros. I'm left with 3/4 x squared plus 0 minus 1. G prime of x is equal to 3/4 x squared minus 1. This machine takes as its input any input that you'd be thinking about putting into this machine and gives as its output the slope of the tangent line to this machine at that point. We calculated earlier that the slope of the tangent line at -2 was equal to 2. We could confirm that if we felt the need. We don't have to, by just figuring out g prime of -2 using this machine. It's 3/4 times -2 squared minus 1. It's 3/4 times 4 minus 1. It's 3 minus 1. It's 2. The same answer we got doing all this calculation up here. Wow. That is an algebraic nightmare. But the good news is all we're going to do in the next 2 videos is this same idea where we're calculating the slope of the tangent line at a point, and then we're calculating the slope of the tangent line where the point is left unspecified as x for different functions. What about a radical function? What about a rational function? Those are the last 2 things we have to do in this section.